Hello and welcome back to V-Science. Ever sat in a flight and wondered what goes on the other side of the window glass? Well, there are so many things that go on that it would take decades to talk about them. But today, we are going to focus on wake turbulences. If you're wondering what that is, it's a mass of high-speed air spinning in a vortex that has enough power to blow off rooftops. But how is such a destructive thing even happening? Well, firstly, the plane's wings are not just flat, they are curved. This means that when the wing is moving through the air particles tend to move faster over the wing of the aircraft than below, creating an area of low pressure above the wing and an area of high pressure below the wing. This generates what is known as lift, making the plane rise higher into the sky. But such a massive disturbance in the air has some consequences. These pressure insularities create something called as a wake turbulence. The larger the plane's wings, the larger the plane's wake turbulence. These wake turbulences, which are not a big deal in the aviation industry now, have caused some serious accidents in the past. This turbulence consists of the wingtip vortex that we discussed earlier. Because of the pressure differences, the air below the wing tends to move into the low pressure area above the wing from the edges of the wingtip. But when the plane wings move ahead, the rotational momentum is conserved, leading to a mass of spinning air trailing behind the aircraft. According to tests done by NASA, these vortices can reach speeds of up to 300 to 350 km per hour. When the Airbus A380 was still in the test phase, experiments led engineers to believe that an aircraft of such a huge wingspan would create wake turbulences that would bring entire airports to standstill. Some wake turbulences even have the power to turn small planes upside down. That is why engineers invented an ingenious device to solve this problem. Wingtip devices. The wingtip vortices actually reduce the lift produced by the aircraft because there is a whole lot of air escaping from the sides. These new wingtip devices greatly minimize the air moving onto the top surface, effectively minimizing wake turbulence and maximizing lift. On November 12, 2001, an American Airlines Airbus A300 crashed into Bell Harbor in New York immediately after takeoff from John F. Kennedy International Airport. The takeoff was minutes after the departure of a Japan Airlines Boeing 747 flight. The massive wake turbulence left behind by the jumbo led to the overuse of the rudder, which ultimately led to the unfortunate crash. Now there are FAA restrictions on the distance and altitude between the leading aircraft and the trailing aircraft. New engineering solutions and restrictions make wake turbulence a mere side fact, all so that we can enjoy a peaceful and comfortable journey on the world's safest mode of transportation. Thanks for watching, and hit that subscribe button if you feel like it.